In the last video, we used the half-angle formula for cosine to find the exact value of the cosine of 165. I also mentioned in that video that you could also use cosine for the sum of two angles to work it out, and I mentioned that the answer would be different, but they were equivalent. So here we're asking, or we're stating here, two formulas were used to find the exact value of 165 degrees. Show that the two answers are equivalent. Well, in that video, using the half-angle formula, let me show you the formulas we used. Cosine of theta over 2 was equal to plus or minus 1 plus cosine theta over 2. And then I said you could use the cosine for the sum of two angles, which breaks down this way. Cosine of A plus B is cosine of A, cosine of B, minus sine of A, sine of B. So in the video I was mentioned here, this is what we had. 165 has to be half of this angle. So we multiply 165 by 2, we get this. And there's the what we worked out. And I put a link to the video in the video description, so I won't go over that right now. And then I said, using this method, we can write cosine of 165 as a sum of two angles. We want those angles to be angles like 30 degrees, 60 degrees, 45 degrees, and so on, because we can get exact values of those using our reference triangle. Or we want angles that have a reference angle of 45, 30, 60. So here, 135 has a reference angle of 45. So everything is set here. We break this down into cosine of 135, cosine of 30. These are all in degrees, minus sine of 135, sine of 30 degrees. So if we set this up then, we just have to compute these out. So the cosine of 135 has a reference angle of 45 degrees. So the cosine of 135 would be the same as the cosine of 45 degrees, which is the square root of 2 over 2. Okay, you're using your 45, 45 reference triangle. Square root of 2. And the angles here are 45, 45, and this is 90 degrees. So the cosine of 45 degrees, adjacent over hypotenuse, that's 1 over the square root of 2, but if you rationalize that, that becomes the square root of 2 over 2. Because 135 is in quadrant 2, the cosine would have to be negative, so I have to put a negative here. Cosine of 30, that's using your 30-60 reference triangle that we looked at in the last video. This is the square root of 3. Positive the square root of 3 over 2. And then this is minus here. Sine of 135. First of all, 135 is in the second quadrant. Sine is always positive, so the answer I put for this one will be positive. So again, reference angle for 135 is 45. So the cosine of 45 is 1 over the radical 2, or radical 2 over 1 over 2. We rationalize, and it's positive. And then again, sine of 30, using our 30-60 reference triangle, is going to be 1/2. So denominators are 4 here, so I'm just going to put this over 4. Then multiply this out here. This is the square root of 6. And multiply here. This is the square root of 2. And I'll put a plus here. I'll just put the minus out in front. I could write it as minus radical 6 minus radical 2 over 4. But that would be your answer using this formula. Okay, let me just clear that for now. So here we have the two answers. This one, of course, is the one I just derived using the cosine of the sum of two angles. So this video then is mainly to confirm that these two are the same. They're equivalent without using a calculator. So there's just a little exercise in algebra if you want. So we want to show that these are equivalent. So we could start with the left side and show that it's the right side, or vice versa. So it's like verifying an identity in your trig class. So let's start with the right side. So the negative here So I'm starting with this. I want to show that this is the same thing as what I have on the left side. And notice the left side has a square root, and then you have some stuff under there. So I'm going to start by saying this is going to equal to the square root, because I know I need a square root on the left side, so I'll leave the 4 there. Then I'm just going to say this is the square root of 2. Plus the square root of 6. Quantity squared. And you should agree with that, right? This is I just put a square there, that's fine, because I have a square root. So the square root of what I have in the radical is just going to give me what I have right here. So that's just, okay. So those are equivalent. So now I'm just going to compute what's in the radicand. Because I see over here on the left side, I have a radical on the outside, and then I have a radical inside. So let's see what happens here. Leave the radical for now. That still stays there. All I'm going to do now is perform the operation inside there. So it's like squaring a binomial, so it'll be radical 2 squared, or just give me a 2 here. So it's just like if you have a squared. That's a squared plus twice the product of the two terms, a and b, plus the second term squared. Just a basic formula from algebra. So this and first term squared, and that's going to be plus twice the product of those two terms. So radical 2 times radical 6, I'm just going to write it as radical 12. And radical 6 squared then is 6. That's over 4. Now let's just simplify inside. Under the radical or the radicand, 2 and 6 is 8. And that's going to give me still with plus twice. Square root of 12 over 4. Can you see it yet or not? And by the way, I have the minus sign. Let's carry through the minus sign here. Minus in front. So again, we're going to show that this has to equal to what I have over here on the right, on the left side. So let's simplify the 12. 12 is 4 times 3. Okay? 12 is 4 times 3. So if I take the square root of 4, that becomes a 2. I bring it outside. I multiply this 2. So then this is going to give me 8. Is still going to be there. Square root of 4 is 2. Comes outside. So that'll give me a plus 4. Radical 3. All over 4. Looking closer now. Got the radical 3 there. And got 8 and 4. Can factor out of 4. So if I factor out of 4, then that would be the square root of 4, and then that product, whatever's left. Well, the square root of 4 is 2. So that 2 is out here now. 2 divides into that 4, giving me 2. And then what's left inside? Factor out of 4 from the 8, I left it with a 2. Plus, and of course I factored out the 4 from radical 3 there, so that left me with radical 3. And there we have it. And of course I have the minus sign here. Here, carry the minus sign here all the way through. And there you have it. The answers are equivalent. Just an exercise and a little bit of algebra. I clear this. Now you could go the other way also. You could go with the left side and show that you get the right side. That one's a little bit more involved, but I do have it set up here in case you want to. So here's going the other way. This is a little bit more involved, but okay, we have this. And I know that I have to wind up with a 4 in the denominator. Okay, this 2 I want it to be a 4. So I said, well, let's make it a 4. I can do that by multiplying the numerator and the denominator by 2. 2 times 2 is 4. That would give it to me. But then I can't go under the radical there. with a 2 because it's not a radical. So I say, well, let's multiply by the square root of 4. Square root of 4 is 2. 2 times 2 is 4. That's okay. Now I can multiply through under the radical into the radicand. So then the 4 multiplies to 2, that's 8. 4 multiplies the coefficient of the radical here, 1. So that gives me this answer right here. And then, again, knowing what I have to wind up with, I break out the 8 into 8 and 2. So I put 6 and 2 is 8. So I just rewrote it. Same thing. 6 and 2 is 8. And then let's look at this then. Then I rewrote this. Six, I wrote it at the square root of 6. Square root of 6 squared. Square root of 3. Plus. And then I wrote this radical 2. Squared. So now let's look at this. If I could factor this out, it's just going to be the same thing now. If I wrote square root of 6 plus the square root of 2. If I factored it out like that, in other words, I'm assuming that the way I wrote it is a perfect square. So is this squared, if I square this out, does it come out to that? Well, let's do this square root here and squared here, so that means that this is going to be the same thing. Assuming this is correct, that step there, this should be the square root of 6 plus the square root of 2. And again, keep in mind, I keep forgetting my minus, so it's just a minus all the way across here. Minus over 4. And that would be your answer, assuming this squared does give me that. So let's check it out. If I square this, obviously it gives me this, which of course is the 6. I square that, that gives me this here, which is of course the 2. That checks out. How about the middle term? When you square a product, a sum this way, it has to be this product, so that would be radical 6 times radical 2, that's radical 12. And that's multiplied by 2, according to the formula. A plus b squared quantity is a squared plus 2ab plus b squared. So does this equal to the middle term there? Well, again, as we did earlier, 12 is 4 times 3. And the square root of 4 is 2. That comes out outside. 2 times 2 gives me 4. Times the square root of 3. So, it checks. They're equivalent. This one's a little bit more involved than the other one, just like identities. When you're working with identities, you have a right side and a left side. You pick one side, try to get the other side. Sometimes it's going to be easier going one way instead of the other. You learn as you go. Thanks for watching. We'll see you next time.